Excerpts from Ancient Forest of the Pacific Northwest by Elliott Norse. Most animals have short lifespans, a year or less. Humans, unusual in so many ways, are in the company of a few species: Asiatic elephants, Andean condors, box turtles, lake sturgeon, and brain corals, as the longest lived animals on Earth. Still, our lifespan of 70 or 80 or 120 years at most seem all too short. Although many plants are also short-lived, some survive centuries or more. The western United States is particularly rich in long-lived trees. At least one bristlecone pine has clung to a bleak, windswept peak. At least one bristlecone pine has clung to a bleak, windswept peak in California's White Mountains for 4,600 years. California's giant sequoias and coast redwoods are very long-lived, as are giant westside conifers. The oldest Alaskan cedar might have burst from its seed while Moses was leading the Israelites out of Egypt. To be enveloped in silence and surrounded by columns of ancient life evokes in many people an image of great European cathedrals. But to many loggers and even some foresters, the trees of cathedral forest are merely overmature, or sensient, or decadent. Individualistic in form, bearing the furrows of scars of time, these oldsters seem wasteful to these loggers, for they occupy ground that could be producing more wood to benefit humankind. They're not paying their way, so they think. Young trees are different. Compared with the forms of the old, young trees are straight and symmetric, often so similar that they seem made with a cookie cutter. In a few decades, usually 3 to 5 decades for a Douglas fir, the amount of leaf tissue stabilizes. Still, the tree continues to grow, reaching maximum height during its 2nd or 3rd century. Like many of us, old-growth conifers continues to add girth long after the height growth has ceased. Giant westside conifers are not the world's fastest-growing trees, but they grow for an exceptionally long time. Grow slow sometimes during their 2nd century, as the energy cost of maintaining their increasing biomass rises while photosynthesis does not. The wood they produce is more valuable than that of younger trees. Not free, fine-grained, strong, and decay-resistant, but the quantity is not as great. As with humans, time takes a toll on survivors. After enduring centuries of storms, fires, insect attacks, many have lost their tops, their trunks have been scarred, and they have rotten spots in their limbs, heart, or lowers. They have become old-growth trees. But bearing Holocaust, gale, or timber sale, many can survive centuries longer. All things being equal, young and mature trees add more wood per acre than old-growth trees. If the only concern is the quantity of wood produced, then old growth is indeed wasteful. Therefore, it makes one kind of economic sense to cut ancient trees, especially since their wood is worth more, and to replace them with fast-growing young trees. But all things are not equal. In addition to producing more valuable timber, old-growth forests provide many essential benefits that young and mature forests do not only in the centuries while trees are old, but for centuries after they die. Indeed, this leads to a conclusion that might seem counterintuitive, but one that researchers find is true in many ways. Dead trees are the life of the forest. A common notion in our youth-oriented society is that forestry is about growing and cutting trees, and that everything good about forests comes from their young, healthy, vigorous growth. But this misses a crucial part of the cycle. A Douglas fir can live more than 1,000 years, and as a downed log can influence the forest for hundreds of years more. Yet, there are numerous strong economic, environmental, and scientific reasons for maintaining our old growth. Although growing trees is important, inordinate emphasis on growth lies at the core of the controversy over forest management in the Northwest. Foresters have been taught that maximizing fiber production is the primary goal of forestry, but new scientific research is demonstrating how this fails to encompass the intricate complexity of forest ecology. Ecologists are discovering how each phase of succession contributes to the productivity of trees as well as to wildlife, climate, hydrology, and the shape of the land itself. We are learning how the seemingly contradictory phenomena of death and life are inextricably intertwined. Nowhere is this relationship more apparent than in the ancient forests of the Pacific Northwest.